Hi, Heather Rainey here for the Make with Ada contest project entry for the 2018-19 contest. My project is porting of Ada to the ST SensorTile. The ST SensorTile doesn't come out too well in this particular video shot, but we'll zoom in shortly. Is a 13mm square board with extremely high density part layout. All this stuff is BGA, high density layout. So there's an L476 CPU, 80 megahertz STM L476, a BLE chip over the SPI interface to it, and a bunch of MEMS sensors. So we have a pressure sensor, we have an accelerometer gyro, an accelerometer magnetometer, and a digital microphone, plus a BLE chip antenna, Bluetooth chip antenna. And all of this has been programmed in the Ada language. So we have a complete stack ported to this environment. So you'll see a communications being run by an Ada stack. All right, so this is the ST BLE sensor app, which is a free download from the App Store, whatever platform you're using. It'll allow you to connect to an ST, well in this case it's going to connect to the SensorTile. So, and because we have an Ada implementation of the SensorTile firmware, it doesn't know that it's not talking to one of its, something, it thinks it's talking to its own stack. But actually, as we see, the name now is Make Ada S, which stands for Make with Ada Server. There's a 7-character limit on the name, I couldn't be too creative. There's our MAC address, and we can select this. It's performing a connection over the air from the Android tablet to the BLE stack over here. So we see on the first page there's a there are 2 temperature sensors in the top left, and they're on a couple different MEMS sensors inside the on the SensorTile and the cradle. Actually, there's one temperature sensor off the SensorTile itself. It's on the cradle. There's a humidity sensor and a pressure sensor. So temperatures, humidity, and the pressure in the corner over there. All right, it's also possible to plot MEMS sensor data. The pressure is not very interesting. Most of the static ones aren't very interesting. But the accelerometer is quite interesting, of course, which we can see here. If we now see the 3 axes moving in concert with my motion. So, you know, if I shake it a little bit, there you go, you get a little bit of a jitter there. All right, so now we can go to the gyro. The gyro is measured in degrees per second and starts out at 0, and not surprisingly. But as you perform rotations around its various axes, you see it start to oscillate. And then finally we have a magnetometer. And the magnetometer is under the influence of the speaker magnets inside this tablet. So you'll see some kind of crazy readings just as it gets near this tablet. But you should know that I do zero it actually. When it was off camera it was zeroed. So basically the closer it gets to these magnets, the worse it gets. And then finally we have one other item, which is the state of the battery charge. There's a driver, we have an Ada driver for the battery charger. This is actually an off SensorTile chip that's on the little cradle that's here. It allows you to observe, well, it allows you to show the state of the charge. Basically, it can be undercharge, charging, or discharging. In this case, we're discharging. We've got 19 milliamps on the way out, and our voltage is just a tidge under 3.9. And the RSSI is also reported, look at that, minus 30. That's actually the best I've seen it, thinking about it now. So when you're really close to your antenna on your host to your client, it's very, very high quality signal rate. So it's like if I take this away from the shot, you'll see the RSSI starts to drop off. So as we come back, there's nothing I do about that. Ada has nothing to do with that. It's just a BLE feature. So this is the setup for the second demonstration we're going to be doing. It's 2 SensorTiles, and they're communicating together over BLE. So the SensorTile on the right, the small one, is actually, that's the server, even though it sort of looks more client-ish, but actually that's the server. And the large board on the left-hand side has the same sensor tile, but it's on a different cradle, and that cradle has a different complement of sensors. Off the tile it has some other sensors. In particular, it has one big difference with the smaller server board. It has a TI PCM 1774 audio codec. Now, with that audio codec, we're able to feed digital audio from the sensor tile directly out to a speaker. So the next demonstration will be involving data coming from the server fed across to the BLE chip on the client board, operating in what's called BLE Central. It's what's called a central, which allows it to basically, it can scan. It's able to scan for the Make with Ada server, connect to it, and then also pull over the characteristic data, which in this particular case is the accelerometer, gyro, and magnetometer. And from that data, it will be able to create some audio tonalities that we'll be able to hear. You may see the LED flashing on the server every time a packet is being sent over the BLE with the accelerometer, gyro, magnetometer data. It flickers the light. This is a good way. I use this for debugging, so that's why it doesn't stay steady. It just flickers away. And the other LED on the client board is on whenever there's audio coming out from the board. It's actually tied to the SAI signal, so that's why it's solid 1, meaning there's an audio signal in play. This is the second part of the demo, where the computer just showed where there was a SensorTile server and a client and a server. So here's the server being drawn closer to a magnetic field, and the frequency on the client board is in proportion to the distance to the magnet, basically. Also, as you use the accelerometer, as you tip away, the volume drops. As we go the other way, the volume increases, basically. That's quite fun. Under the influence of the magnet, you can sort of see the sort of arpeggiated effect as the magnet comes in and out of the sphere of influence of the MEMS sensor. And again, this is a volume, so you can just turn the thing over to get higher volume or lower. And so it allows you, this is sort of like a crude theremin, if you will. It allows you to, based on your distance to this magnet, send audio data to the speaker. And it's all being done by Ada over Bluetooth, the BLE connection, and it's real-time data being sent over with a fully coded BLE stack in Ada. So that's my submission for Make with Ada. Thank you.